there is something that the critical mathematical eye might use to judge that this problem is faulty. And it might not be faulty, but let us see why it will be judged to be faulty and also why it might not be faulty. We will begin by magnifying the right-angled triangle that we have there, and in the magnification everything is preserved, all of the dimensions, angles, etc. According to Pythagoras, the square of the longest side, which is the hypotenuse of a right-angled triangle, is equal to the sum of the squares of the other two sides. According to what we have there, then 12 squared should be equal to 8 squared plus 9 squared if we adhere to Pythagoras' theorem. In this case, it is not quite so, because 12 squared is not exactly equal to 8 squared plus 9 squared. We don't have to make any calculation in order to show that it is not quite right. So we could square 12, square 8, square 9, put them together, and we will see that the left-hand side is not quite equal to the right-hand side. But we might take another logical approach in determining that 12 squared is not actually equal to 8 squared plus 9 squared. The square of an even number is even. If we square 12, which is an even number, the result will be even. While the square of an odd number is odd. Also, the sum of an odd number and an even number is odd. So 12 squared, 12 is even, 12 squared will be even. 8 squared will also be even because 8 is even. 9 squared will be odd because 9 is odd. Now the sum of an even number and an odd number is odd. But 12 squared is even. An even number cannot be equal to an odd number. Because even cannot be equal to odd, then we are sure that 12 squared is not equal to 8 squared plus 9 squared. But there must be a good reason for the examiners being comfortable with that 8, 9, 12 right-angled triangle, and we will investigate it. Although we see, without actually squaring the numbers, that 12 squared could not be equal to 8 squared plus 9 squared, which should have been the case if the triangle were right-angled. Let us say that we did not know the hypotenuse, but the lengths of the other sides were given. We don't know the hypotenuse, but the lengths of the other sides are given. By Pythagoras' theorem, 8 squared is equal to 8 squared plus 9 squared. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Make h the subject of the formula by finding the square root of both sides. So when we find the square root of h squared, the square root and the square operations will have a cancelling effect on each other, being the inverse of each other. And of course, we will maintain that square root on the right-hand side. 8 squared is 64, 9 squared is 81. Add them together, we get 145, which we know is not the square of 12. But we will admit before that it is actually very close. We know that 12 squared is equal to 144. Therefore, the square root of 45 is not equal to 12, at least not exactly equal to 12. But we see that the numbers are quite close. The square root of 145 is actually 12.042. The answer that we got is so close that if we round it to one decimal place, the result is still 12. The examiners were therefore not mentally deranged to make the slant edge 12 meters. We know by Pythagoras it's not exactly equal, but it is extremely close. If we round it to one decimal place, the result is still going to be 12. Therefore, we are sure that the examiner using 12 is not out of their wits. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.